Hello students. In the last class we have studied the definition of specific conductance and its SI unit and also the definition of molar conductance along with the SI unit. Now we will study how these specific conductance and also molar conductance varies with concentration. Okay, so for that we will consider one of the solution. We will study only the variation of specific conductance with concentration. For that we will consider one of the solution in a container. So this is nothing but the container. So in this container we will consider a solution. So this solution is having length 1 meter and area of cross section is 1 meter square. Okay, so we will measure the specific conductance through this solution. So we will get some value of specific conductance. Okay, now by the addition of water, if we add water into this solution so that the volume of this solution gets increased. The volume of this solution gets increased. So with increase in the volume, the particles present in this solution gets distributed throughout the solution. So by the movement of particles in this area, due to the movement of particles from one place to another place, in this area there is the presence of only few number of particles. Generally, conductance is due to the presence of the number of particles or ions. So by the addition of water into the solution, the concentration of solution gets reduced and the volume gets increased. So because of increase in the volume, the particles gets distributed and in this specified area, the number of particles gets reduced. So because of decrease in the number of particles, the specific conductance only in this area also gets reduced. So that means upon dilution, concentration of solution gets reduced so that the specific conductance also gets reduced. Okay, so that is the thing but the effect of concentration on the specific conductance. Now, we will go through the molar conductance. What is the effect of concentration on molar conductance? So that is to be studied by taking one of the example like this. So we will consider a solution in this area. So this solution is having a concentration of 1 molar. That means 1 mole of solute is dissolved in 1 liter of solvent. So that means in this area there is a presence of 1 molar solution. We will measure the molar conductance through this solution. So let lambda m be the molar conductance through this solution. Now we will add some water into this solution so that the volume of the solution gets increased. As the volume of the solution gets increased, the concentration gets reduced. So concentration of solution gets reduced upon dilution. Dilution means addition of water. Okay, so by the addition of water, the volume gets increased and the concentration of that solution obtained gets reduced. So because of increase in the volume, the particles present in this area gets distributed throughout the solution. So by the addition of water into this solution, the volume gets increased. So because of increase in the volume, the particles present in this area gets distributed throughout the solution. Okay, so we have to measure the molar conductance of this solution also. So we are not measuring the molar conductance only in this area. We have to measure the molar conductance through the whole solution. Since the particles are moving away from one another because of increase in the volume, so that there is no force of attraction between the particles, or the force of attraction between the oppositely charged particles gets reduced. Because of decrease in the force of attraction between the oppositely charged particles, all the particles which are present in this solution are involved in the conduction of electricity, so that the molar conductance gets increased upon dilution. That means the molar conductance of a solution gets increased upon dilution. So this is nothing but the effect of concentration on the molar conductance. Now we will summarize. Specific conductance gets decreased with dilution. That means upon dilution the concentration of solution gets reduced so that the specific conductance also gets reduced. Now upon dilution the concentration of solution gets reduced, whereas the molar conductance, lambda m is nothing but the molar conductance, it gets increased. Molar conductance increases upon dilution, whereas specific conductance decreases upon dilution. Okay, so if we go on add water into 1 molar solution, by the addition of some more amount of water into 1 molar solution, the volume of the solution goes on gets increased. So by the addition of 1 liter, 2 liter, 3 liter, 4 liters of water and so on, the concentration of solution goes on decreases and the volume of the solution goes on increases. So that the particles present in that solution gets distributed throughout the solution so that the particles move far away from one another. So because of the movement of the particles far away from one another, so that the attractive force between the oppositely charged particles gets very low. It becomes very low, or it totally becomes equal to 0. Under that condition, the molar conductance is very high. That means after infinite dilution means we are adding a very high volume of water. Much amount of water is adding into the solution so that the dilution can be taken as infinite dilution. That means we are adding more amount of water into the solution so that the concentration of that solution gets very low. That will become very low. So concentration of solution gets reduced. Almost the concentration of solution becomes equal to 0 upon infinite dilution. Under that condition, the molar conductance is very high. The molar conductance of that solution becomes very high. So that high molar conductance can be taken as lambda naught m. So lambda naught m can be taken as the molar conductance at infinite dilution, or molar conductance of a solution at 0 concentration, or molar conductance at infinite dilution can be taken as lambda naught m. So this is nothing but the representation of molar conductance at infinite dilution. Okay, so we will measure the molar conductance of a solution